let's look at some terms. The process of computing the derivative is called differentiation. If a function has a derivative at a point, then it is said to be differentiable at that point. If a function is differentiable at every point in its domain, then it is called a differentiable function. So, differentiation, differentiable, and differentiable function. And we have seen the concept of continuity. Okay, continuity of a function means that for every small change in the value of x, there is a small change in the function. Okay, so let's look at it in combination, differentiability and continuity. I'll make a statement. If a function f of x is differentiable at x equal to a, then f of x is continuous at x equal to a. Okay, this is a very important point. If a function f of x is differentiable at x equal to a, then f of x is continuous at x equal to a. But the converse is not. So if a function is differentiable at x equal to a, the f of x is continuous at x equal to a. But if a function is continuous at x equal to a, then it need not be differentiable at x equal to a. Let's see with an example what we mean by this. Let's say f of x equal to absolute value of x. Now we know that this is a continuous function, which means, to be more precise, it is continuous at x equal to 0. Now why are we interested at x equal to 0? Because if you remember, the graph of this is like this. So here everywhere else it's okay. It's only the at x equal to 0 that it seems to suddenly change its direction. That's why we are interested in at x equal to 0. Let's differentiate it at x equal to 0. So f prime of 0 is equal to limit as x approaches 0 of f of x minus f of 0 by x minus 0. Now let's look at when x is greater than and when x is less than. So f of x is equal to absolute value of x is equal to x if x is greater than or equal to 0. So when x is greater than or equal to 0, actually let's make the reverse statement. If x is greater than or equal to 0, then that means x is a positive number. If it is positive, then it is x. Yes. If x is less than or equal to 0, now here x is negative. So f of x equal to, it's still x itself, but here x is negative, here it is positive. So since things are interesting at 0, let's look at one-sided limits as we get closer and closer to 0 from left and right. So limit as x approaches 0 from the positive side, f of x minus f of 0 by x minus 0. This is equal to limit as x approaches 0 from the positive side of x by x. Now what happens? However close we get to 0 from the positive side, so let's say 0.0001, absolute value of this is what? Same. So there is no difference. So let me remove that. These two get cut off. We are left with 1. So it is 1. Okay, now let's look at the limit from the negative side. Limit as x approaches 0 from the negative side. Now what happens? Now in the same example, 0.0001 absolute value of this divided by minus 0.0001. Now the in this case, in the numerator case, when we remove the absolute sign, the minus sign disappears, but the minus sign remains in the denominator. So when they get cancelled, we are left with minus 1. So minus. So as you can see, the left hand limit or left hand derivative is not equal to right hand derivative. So which means what? Which means that it is this function is continuous but not differentiable at x equal to 0. Let's look at another example. F of x is equal to, let's look at a more complicated example, x e to the power of minus 1 by absolute value of x plus 1 by x. This is when x is not equal to 0, and it is 0 when x is equal to, now here the complicated thing is the exponent. So let's first simplify that. 1 by absolute value of x plus 1 by x. So here there are two situations. So let's look at x greater than 0. Absolute value of x will be x itself, which is 2 by x. When x is less than 0, absolute value of a negative number would be, so this will remain as x, whereas this will become minus 1 by x. So which means 0. Okay, that's one point. Another point is, as x gets closer and closer to 0, what happens to this expression? Simplest way of figuring it out is 2 divided by 1 is 2. 2 divided by 1 is 2. 2 divided by 0.1, which is 10th of 1, is going to be 20. Yes. 2 by 0.1. 0.01, 200. 0.001, 2000. Yes. So you can imagine, as it gets closer and closer to 0, this will actually tend to infinity. So remember this. When this is equal to 0, f of x will be equal to 0. Now let's look at the continuity. Limit as x approaches 0 from the plus side. What happens? X e to the power of, now from the plus side when it comes, that is x is positive. So when it is greater than 0. So this we can simplify to 2 by e to the power of minus 2 by x. And when we actually take the limit, okay, I didn't mention the limit statement. Limit as x approaches 0 from the positive side of x e to the power of minus 2 by x. When we actually take the limit, x will tend to 0 times e to the power of, what will happen? Minus infinity. So which means this will be 0. Okay. Let's look at it from the negative side. When we come from the negative side, what happens? X e to the power of, it's directly 0. When x is less than 0, it is 0. So e to the power of 0. Remember, when it is less than 0, we have looked at the exponent. Exponent will become 0. So e to the power of 0 is 1. So limit will be what? It will be 0. Now f of x limit at 0. Right? We have looked at it from the positive side. We have looked at it from the negative side. Let's look at it. X f of x is equal to 0. Now this implies the function is continuous. Okay, so the function is continuous. Now let's look at differentiability. So which means we have to find the derivative at 0. Again, we have to look at it from both the sides. So f prime of 0 from the positive side is equal to limit as x approaches 0 from the positive side of f of x minus f of 0 divided by x minus 0. Now this is what? This is limit as x approaches 0 from the positive side, x e to the power of minus 2 by x. Here x gets cancelled and we are left with minus 2 by x. Not just that, it is the limit. Now let's take the limit. Remember, 2 by x tends to infinity. This can be written as limit as x approaches 0 from the positive side 1 by e to the power of 2 by x. Right? Now we know that as x approaches 0, gets closer and closer to 0, 2 by x will become infinity. Right? And again, from a limit point of view, 1 by infinity tends to 0. So which means equal to 0. So our right hand limit is equal to 0. Now let's look at it from the other side. As limit x approaches 0 from the negative side. What will happen? Again, start from f of 0 is 0. So f of x by x, which is equal to negative. So when it is negative, it is x. So limit as x approaches 0 from the negative side, it is x by x, which is equal to 1. X by x, which is equal to limit as x approaches 0 from the negative side 1, which is nothing but 1. So which means right hand derivative is not equal to left hand derivative. So which means f prime of 0 does not exist. That means it is not differentiable at 0, at x equal to 0. So basically, you can find whether it is a continuous function or not. For continuity, f of a should exist. Limit as x approaches a of f of x exists. And the third is, so which means here it is left hand limit is equal to right hand limit. Limit as x approaches a, f of x is equal to f of a. Okay, so these three conditions for continuous function. Differentiability is what? So as far as differentiability is concerned, we just have to figure out whether the left hand derivative is equal to right hand derivative, which means f prime of a from the positive side is equal to f prime of a from the negative side. I think that's enough for today. Bye for now. Please go to the about page of my channel, and here you will find various links for each topic. These are Excel workbooks which I have been using in many of my videos. Download it and practice.